Hi friends, my name is Nitin Kunal Reddy. Today I am going to discuss about tool or die steels. Tool steels are also known as die steels as they are popularly made of dies. Tool steels are high quality alloys used for tools, dies, etc. Properties of tool steels are they have high wear resistance, high hardenability, good wear resistance, little risk of cracking during hardening. Classification of tool steels. Tool steels are classified into four types: cold work tool steels, hot work tool steels, high speed tool steels, special purpose tool steels. Firstly, we are going to discuss about cold work tool steels. Cold work tool steels are used for cold working of metals. They have a very good wear resistance and a very good hardness. Cold work tool steels are used to manufacture dies by hardening process. There are four types of hardening process: water hardening steels, popularly known as W series; oil hardening steels, popularly known as O series; air hardening steels, popularly known as A series; high carbon and high chromium steels, popularly known as D series. Firstly, we are going to discuss about water hardening steels. Water hardening steels are mainly known as plain carbon steels because it consists of carbon 0.6 to 1.4%. They are mainly for the impact and shock loading conditions. They are hardened and quenched by water. Applications of water hardening steels: thread dies, blanking dies, downing dies, drills, forming tools, chisels, hammers, razors, knives. Secondly, oil hardening tool steels. Steels with small amount of copper, manganese, chromium, molybdenum, vanadium. Due to this hardenability is better than water hardening steels. Oil hardened steels are quenched. Applications of oil hardening tool steels: forming dies, blanking dies, cutting tools, shear lace. Nextly, air hardening steels consist of molybdenum. Air hardening steels. They consist of manganese, chromium, molybdenum, vanadium, alloying elements 75%. They have a very good wear resistance and good depth of hardening. Thread cutting, drowning dies and punches. They are the applications of high hardening tool steels. High carbon and high carbon chromium steels. They have a very high hardenability. They are hardened by oil or air quenching. They consist of 1.5% of carbon, 12% of chromium, vanadium, molybdenum, small amounts. Applications of high carbon and high chromium steels: drawing dies, forming blanking, coining dies, thread rolling dies, bushing dies, punching. So the next type of tool steels are hot work tool steels. It mainly consists of hot working of elements such as stamping, drawing, forming, planing, extruding, upsetting. It has a very good strength, toughness, hardness, with resistance. They are classified into three types: chromium tool steels, tungsten tool steels, molybdenum tool steels. Firstly, chromium tool steels. It consists of a chromium 3 to 7% and small amounts of copper, molybdenum, vanadium, and carbon of 0.55%. It has a high toughness and raised for die casting dies, extrusion dies, forging dies. Tungsten tool steels. It consists of 18% of tungsten, 2 to 12% of chromium, carbon up to 3%. It has excellent hot hardness, resistance to wear, and elevated temperature. Applications are forging dies, hot punches. Molybdenum toolkits. It consists of 14 to 20% of molybdenum and small amounts of chromium, vanadium, tungsten, carbon. Resistance up to high temperature and toughness is required. High speed tool steels. Car withstand up to hardness up to temperature of 550 degrees Celsius. Use it for high speed cutting of metals, high wear resistance and cutting ability. Tungsten, HSS and molybdenum. High speed tool steels are classified into two types: tungsten HSS and molybdenum steels. High amount of tungsten 18% and other elements such as chromium, vanadium, cobalt, maximum of 5%. Molybdenum steels. Molybdenum consists of 18% and carbon consists of 0.05% and tungsten consists of 0.6% and chromium consists of 4%. They are mainly used for cutting ability and high temperature applications, drills, taps, milling cutter, punches, drawing dies, rather tools, etc. Nextly, special purpose tool steels. Shock resistant tool steels. It mainly Special purpose tool steels are classified into three types: shock resistant tool steels, carbon tungsten tool steels, mold steels. Shock resistant tool steels: 0.5% of carbon, manganese, chromium, tungsten, molybdenum, vanadium, silicon 2%. On adding the carbides of chromium, vanadium, tungsten, molybdenum, it increases the shock resistance hardness. Applications are punches, chisels, forming dies. Carbon tungsten tool steels. Carbon and tungsten. Applications are high wear resistance, abrasive wear resistance is preferred, branches, taps, reamers, bushing tools. Mold steels. It consists of 0.2% carbon and contains chromium, making only for molds. Heat resistant tools. They withstand a very high temperature, have high hardness, wear resistance, high creep resistance. Refractory materials are used. It consists of tungsten, molybdenum, chromium, cobalt, copper alloys are used for withstanding high temperature. Applications are steams, pipelines, steam downs, jet engines, rockets, gas turbines, boilers. In high alloy tool steels, we consist of stainless steels also. So, stainless steels. When 11.5% or more chromium is added to iron, a plane of chromium oxide forms spontaneously on the surface. This acts as a barrier to further oxidation or corrosion. As the steels cannot be stained easily, it is called as stainless steels. Types of stainless steels. There are three types of stainless steels: authentic, ferritic, martensic. Firstly, we are going to discuss about authentic stainless steels. They possess a austenitic structure and a high room temperature. They have a very high corrosion resistance of all stainless steels. They are ductile in nature. They are non-magnetic, poor hardness. It consists of 0.25% of carbon, 10% of manganese, 2% of silicon, 2.26% of chromium, and 22% of nickel, and phosphorus and sulfur of 2%. Applications of authentic stainless steel are engine parts, food processing kettles, dairy milk pots, heat exchangers, cooking utensils. Ferritic stainless steels possess microstructure which is ferritic. They have a very low carbon to chromium ratio. They have a magnetic and good inductility. They are very soft, ductile, and have corrosion resistance. It consists of 0.20% of carbon, silicon 1%, chromium 25%, manganese 1.5%, silicon and nickel of 2%. Applications of ferritic stainless steels are screws and fittings, heating elements in furnaces, oil burner parts. Martensitic stainless steels. Martensitic microstructures. uh, they have a very high carbon to chromium ratio. They can be cold worked without any differentiability, good toughness, corrosion resistance, and a carbon of 2%, silicon of 2%, manganese 1%, chromium 18%. Pump value parts, turbine buckets, surgical equipment. So today's discussed topics are: we have discussed high alloy tool steels. They consist of two types: tool steels and the other is stainless steels. In tool steels, we have discussed various topics which are used for various applications. And in stainless steels, we have discussed three types of stainless steels. So This is my topic. Thank you.